The sheer scale of Baalbek's foundation forces structural engineers to confront a terrifying mathematical reality. In 2014, German archaeologists pulled a 1,650-ton limestone block from the earth beneath the ancient quarry, the largest ever carved by human hands. For decades, historians assumed these giants were left in the dirt because the builders simply realized they couldn't move them. But forensic analysis of Baalbek's foundation proved something far more disturbing. This massive stone was abandoned because it failed a strict quality check, which means these ancient engineers possessed a mechanical system they fully trusted to move 3.3 million pounds of dead weight. And that system has never been found. The evidence is already visible. The tool marks on the 1,650-ton abandoned block are identical to the tool marks on the 800-ton stone sitting 20 feet in the air at the temple. Same builders, same era, same system, the one we cannot explain. To comprehend the magnitude of this engineering problem, we must first examine the stones that actually made it to the temple site. Set into the retaining wall of the Temple of Jupiter complex is a formation known as the Trilithon. This is a grouping of 3 massive limestone blocks, each weighing approximately 800 tons, or 1.6 million pounds. These are not resting on the ground. They were raised and set into the wall roughly 20 feet or 6 meters above the base of the foundation. Despite their unimaginable mass, these 800-ton monoliths are fitted together so precisely that a single blade of grass or a piece of paper cannot be slid between the joints. They were laid without a single drop of mortar, relying entirely on gravity, perfectly calculated geometric dressing, and an unparalleled understanding of load-bearing physics. For decades, traditional historians have attempted to explain the transport of these megaliths using the standard model of ancient construction: brute manpower, wooden rollers, and miles of thick hemp rope. However, when structural engineers apply the actual mathematics of friction, tensile strength, and static loads to this model, the theory completely collapses. To move a single 800-ton block on a flat surface using wooden rollers, engineers calculate it would require the synchronized pulling force of an estimated 40,000 men. This introduces a spatial paradox. You cannot physically attach 40,000 men to a single stone block. The footprint required for the workers, the massive network of ropes, and the exact synchronization needed to inch the stone forward makes human pulling a logistical and mathematical impossibility. Furthermore, the tensile strength of ancient hemp or flax ropes would catastrophically fail. Under the sheer friction and static load of an 800-ton mass, the ropes would violently snap before the stone moved a single inch, unless an unprecedented, heavily geared mechanical advantage was utilized. In 1977, researcher Jean-Pierre Adam conducted a strict physics-based study on the Baalbek site to find a mathematically viable solution. He hypothesized that the builders did not rely on pulling the stones with forward marching men, but instead utilized massive, heavily anchored wooden capstans, which are essentially heavy-duty winches. Adam calculated that by using 6 massive capstans, each manned by 24 workers, a team of just 144 men could generate a traction power of over 78,000 kilograms through mechanical advantage. This theory is brilliant because it solves the spatial paradox of needing tens of thousands of men. It provides a highly efficient, geared solution to dragging an 800-ton weight horizontally across a prepared track. This theory is further supported by the exact topography of the Baalbek site. A persistent myth is that these stones were dragged uphill from the quarry. Geomatics and precise surveying prove the opposite. The ancient quarry sits at a slightly higher elevation than the temple complex, about 800 to 900 meters away. The builders were not dragging an 800-ton monolith uphill. They were tasked with controlling a 1.6 million-pound descent. In structural engineering, managing the downward momentum of an 800-ton mass on a slight grade is arguably more dangerous than pulling it flat. If the stone gained even a fraction of unchecked momentum, it would instantly crush its wooden rollers into splinters, snap its tethers, and obliterate anything in its path. The Capstan Theory provides the necessary braking mechanism to carefully lower the stone toward the construction site. But solving the horizontal problem revealed something the engineers never anticipated: a second obstacle that has never been explained. What happens when the stone arrives at the foundation and needs to go 20 feet straight up? That's where every conventional model on record completely breaks down. Roman engineering was undeniably brilliant. They relied heavily on the polyspastos, a sophisticated heavy-duty crane utilizing a block and tackle system. But we must look at the hard material limits of antiquity. The largest known Roman cranes, even when described by master architects like Vitruvius, could safely lift perhaps 10 to 15 tons. In a highly modified multi-crane mega-rig setup, they might have been capable of hoisting 60 metric tons. To scale a wooden crane system to lift 800 tons is a material impossibility. The compressive force of 1.6 million pounds would instantly and violently shatter the thickest timber available in the ancient world. The iron axles required for the pulleys would shear and warp under the catastrophic stress. To hoist 800 tons 20 feet vertically and set it perfectly flush against another stone without shattering the edges requires a level of hydraulic or geared lifting technology that we did not reinvent until the modern industrial era. This is not a gap in our knowledge. It is a gap in the historical record itself. Something capable of lifting 800 tons vertically with millimeter precision was used at Baalbek and was never documented by any Roman, Greek, or Egyptian engineer who came after. This brings us back to the staggering 2014 discovery by the German Archaeological Institute, which forces us to rethink the upper limits of this forgotten engineering. Beneath the famous 1,000-ton stone of the pregnant woman in the quarry, Dr. Janine Abdulmasi's team uncovered the third monolith. Measuring 19.6 meters long, 6 meters wide, and 5.5 meters high, this 1,650-ton giant is perfectly carved. To put this into perspective, this single block of limestone weighs more than 2 fully loaded commercial airliners. And yet, the tool marks on this newly discovered monolith perfectly match the tool marks found on the 800-ton Trilithon stones at the temple. This confirms they were quarried using the exact same methods by the exact same builders during the exact same era. Before a single block was moved, the extraction process itself required an immense, highly coordinated workforce. The builders had to carve deep, narrow trenches into the solid bedrock, isolating the massive rectangular blocks while they were still attached at the base. Working in these confined spaces with bronze or early iron chisels means the extraction alone would have taken years of continuous, grueling labor. Yet the cuts are perfectly straight and mathematically precise, showing no deviation across a length of nearly 20 meters. But why were the largest stones left in the quarry? The forensic stone analysis conducted by the archaeological team revealed a profound truth. Upon examining the 1,000-ton block sitting above the new discovery, engineers noted that the stone quality on one specific edge was remarkably poor. The ancient engineers did not abandon the project because they lacked the machinery. They abandoned the stone because it failed their strict quality control. They understood the sheer physics of shear stress. They knew that if they attempted to lift or move a 1,000-ton block with a microscopic fault line or weak edge, the stone would catastrophically crack under its own immense weight during transport. We know the Romans eventually built the spectacular columns of the Temple of Jupiter over this site. But looking at the forensic evidence of these abandoned 1,650-ton giants, could standard Roman engineering truly handle this scale? Or are we looking at the remnants of a lost, highly advanced mechanical system? Do you believe the Romans built this? Or is something else buried in that quarry? Drop your answer below. This implies an astonishing level of structural testing, likely utilizing acoustic resonance or advanced visual stress testing methods to determine the internal integrity of the limestone before it was fully detached from the bedrock. The architects who carved the 1,650-ton block fully intended to transport it. They were not experimenting. They were executing a planned industrial extraction. They possessed a mechanical lifting and transport system that they trusted implicitly to handle 3.3 million pounds of dead weight. They only stopped because the raw material of the Earth itself was not strong enough to survive the journey. We are looking at an anomalous spike in human technological capacity, a highly advanced understanding of load-bearing physics, mechanical advantage, and structural engineering that was utilized to build the foundation of Baalbek and then completely vanished from the historical record. Here at Ancient Chronicles HD, our mission is to strip away the myth, ignore the fringe speculation, and examine the raw, verified data of human history. We analyze the impossible engineering of the past through the strict lens of structural physics and architectural forensics. If you demand serious, fact-based investigations into the anomalies of the ancient world, make sure you are subscribed to the channel and have notifications turned on so you never miss a breakthrough. When we step back and look at the foundation as a whole, the sheer ambition of the project is staggering. The Trilithon is just one layer of this massive megalithic platform. Below the 800-ton stones are blocks weighing 300 to 400 tons each. Furthermore, the structural integrity of the Baalbek foundation suggests an advanced understanding of seismic activity. The massive stones are fitted together with such precision that they can absorb and distribute the shock waves of earthquakes, which are common in the region. The lack of mortar allows the stones to shift slightly and resettle without cracking or bringing down the entire structure. This isn't just heavy lifting, it is dynamic, earthquake-resistant engineering achieved on a megalithic scale. The entire complex is a testament to a civilization that viewed massive, monolithic construction not as a challenge, but as an established industrial standard. When the Romans arrived centuries later to build the Temple of Jupiter, they recognized the undeniable strategic and architectural value of this existing platform. They built their magnificent classic columns directly on top of it. Yet even the Romans, with their vast empire, endless resources, and masterful engineering corps, never attempted to quarry or move stones of the 800-ton class. They built with smaller, more manageable blocks. The original builders of the Baalbek Foundation operated on a scale that made the Roman Empire look entirely pragmatic by comparison. It raises the ultimate question: what kind of society designs a foundation so massive that it requires the invention of physics-defying transport systems, only to disappear and leave the ultimate test of their technology buried in a Lebanese quarry? So the real question isn't just how they moved the stones, it's what happened to every trace of the system that moved them, and whether someone made sure we'd never find it. The precision and scale of Baalbek force us to reevaluate everything we thought we knew about the limitations of ancient masonry. But this site in Lebanon is not the only place on Earth where gravity and stone were mastered without the use of modern machinery. If you want to see how an entire sprawling metropolis was constructed with master masonry that defies gravity, built entirely without a single drop of mortar, click the video on your screen right now to explore the impossible engineering of Great Zimbabwe. I will see you there.